Whenever aspiring developers ask me what type of project they should do for their first game, my response is always the same: Pong. However, I have found that I've never really been able to find a good tutorial that I can be confident in and point them to, and it got me thinking that I actually hadn't spent any time building Pong in quite some time. For really well over a decade would probably be the last time that I ever built a Pong game. And as an industry veteran now, I figured it might be interesting to take a crack at it, build a Pong implementation, and build a tutorial around that. And so that's what we're going to be building in this video. We're going to be building Pong, and in fact the version of Pong that you're seeing on the screen right now is exactly what we're going to be building. That is the final product, and we'll be building it in Unreal Engine. Now, I've chosen Unreal Engine really just because it offers the blueprint scripting language, which I think is a great language for visualizing code. This programming tutorial is not going to be your typical programming tutorial. We are going to jump right into just building the project, and if you don't understand what's happening, just go with it. Just build it and understand how things connect and flow and work together. That's really what you have to understand to become a programmer. So that's what we're going to be doing. Let's get started. Alright, now that we have gotten the introduction out of the way, let's jump into the Epic Games Launcher. Now, if you don't have the Epic Games Launcher, you can just Google Epic Games Launcher or install it from the Microsoft Store or whatever, the Mac App Store. Obviously, I'm running Windows here, so if you're on Mac, your experience might be a little bit different. Before we begin, let's go ahead and grab the free games. I've already grabbed them for this period of time, but if you haven't grabbed them yet and are new to the Epic Games Launcher, there's free games every couple of weeks, and it's really nice. You can build up a pretty big collection. Same thing with Fab. If we go over to Fab here, Fab is like the Epic Games Store, but for assets for games, and there are these limited time free assets. So if you click on those, much like the free games in the Epic Launcher, there are assets that are on a rotational free basis and are pretty nice. Sometimes you get some pretty cool stuff in there. So with that being said, let's go over to the Unreal Engine tab. Now, the version of Unreal Engine that I've decided to use for this video is the oldest version, 4.0.2. I want this to be the maximum accessible as possible. This isn't really a tutorial about Unreal Engine so much as it is about programming and using Unreal Engine as a platform to talk about programming. So Unreal 4.0.2 is the oldest version of Unreal 4 that you can install. It was released like around 2013 or 2014, and I tested this project on a computer which had a i5, a first generation i5 with 8 gigabytes of RAM and an NVIDIA GTX 750 Ti. So nothing over the top there. You could pretty much pick that computer up for $150 today. No problem. Really the most important thing about Unreal, even old versions like this, on top of having some sort of accelerator, probably NVIDIA or something like that, but the 8 gigabytes of RAM minimum really is required. Any less than that, you'll probably get like freezes or crashes and stuff like that. But most computers, released over the last decade or so have that. So most people should be able to do this tutorial. Now, the project that we're going to build, of course, is going to be Pong. And let's go ahead, and if you haven't installed the engine, you can just click on the plus up above, select the engine version you'd like. Now, this project can be built in any Unreal Engine version, like there's nothing special about it. So if you want to follow along exactly, you can pick 4.02, which I no longer have in my list as it's already installed, or 4.1, 4.2, 4.3, or you can go up to the latest 5.7.3. But just be aware that they have made changes to the UI and things. So while the overall flow and process of this project is the same, the way that you might access certain features of the engine will have changed over the versions. So if you're new to Unreal Engine, I would highly recommend installing 4.0.2 to follow along with this video. So let's launch the engine here, and it's gonna pop up. We can close that. And yeah. So this is what you're gonna get when you first sort of start the engine. This is your project browser. Now we're going to create a new blank project. There's a few different templates and stuff, but we're not going to use those. We're just going to create something with no code. If you wanted to use C++ with 4.0.2, you need Visual Studio 2013, which is no longer free. So there is a version on the web archive, but we're not going to do C++ in this video. So all of it will be Blueprint, and we can just use the blank project here. We're not going to include the starter content, as we don't need it for this. And we can call the project, I'm not going to call mine Pong, because Pong is Atari's thing. So I'll call it Paddle War. And yeah, create the project here. Unreal Engine's going to pop up. Now, if it's your first time launching the version of the engine, I actually reset my settings so I could recreate this experience for you, but this is what you're going to get. So you're going to get this Welcome to Unreal Engine tutorial, and it's going to, if you go through and click next, you're going to get all of these different things. It's going to talk about it. Take your time, you know, read about all of these different things. I will talk about the interface and how Unreal works and things, but unlike most tutorials, we're not going to be kind of going over the whole UI and then language features and all that. We're going to be jumping right into the project. And I'll explain things kind of as needed. I think it's a better approach, or it's a different approach. You let me know if you like this approach or not. That's sort of the purpose of this video, is experimenting. So what we're going to do first is we're just going to select File and New Level. And we're just going to select an empty level. That's going to clear out our screen, and that nice visual goes away, and now we have the void. Just empty space and a nice grid showing us where 0, 0, and there is a vertical line here that you can't see. But it does exist. There's a 0, 0, 0, and it would be blue if it was in the display. But this is our grid coordinate system here that we're seeing, and all coordinates within a game engine exist within this space. Now, it's also a useful way to sort of display how programming works. So that's a big reason why I've chosen Unreal. Now, before we get started, I'm going to just sort of configure some aspects of the interface here. So we're going to go to Edit and then Editor Preferences. And we can just look through these editor preferences. Now, if you take this tab and drag it up here, it'll actually dock, which I like to do for the editor preferences here. As you can see, my language and region are set. And if you click on these little down arrows, there's more options, and you'll see these all over the interface. So you can change things like the colors. And a big reason why I wanted to use 4.0.2 versus other versions of Unreal Engine is all of these option screens are like 10 times larger in future versions of Unreal. So 4.0.2 has a nice small set of options, a nice small set of plugins, and is much easier to explain, I think, in a video instead of like wading through a bazillion options. I can kind of cover the whole set here. And then, you know, if people like this video and I ever end up doing future videos, maybe we'll like jump to 4.1 and cover the options there, jump to 4.2, cover the options there, build small projects with them, and sort of move on that way. I'm not really sure yet. I just knew that I wanted to have a small set of options. So you can actually, use small title bar icons. Now, normally I do like doing this as it gives me more real estate, and I'll show you what that looks like here. So if we switch over, now you'll see these are very small. And I do like that. However, for the purpose of the video, I'm going to leave them big. You can also get window animations. So when they're enabled, they things kind of pop in like that, right? Like it like slides and stuff. And if you don't have it, they just appear. They don't really do anything. I would suggest leaving them off, especially if you're on a machine that's a little bit on the underpowered side. Show friendly variable names. Basically what this does is it sticks a space in between variable names that don't actually have a space in them. And often I do leave this on. However, for the purpose of this tutorial, we're actually going to turn this off. We want to see the real variable names. And finally, they have this expand configuration menus in the expanded menu. And if you check this, all configuration menus will start expanded. So if we go back, maybe it won't apply to this because I have to reopen it or something. But yeah, they'll all start expanded. But we'll leave that off to keep the UI nice and tidy. So moving on, we've got our keyboard shortcuts here. Now, where I'm not going to go through all these, you can configure keyboard shortcuts how you'd like. I'm just going to leave everything default. We've got loading and saving. Now, we can choose whether we load the default level at startup. We're not going to do that. Now, you see how all the variable names now say B load default level at startup? That's because they don't have the, we don't have the friendly names checked. So that gives us the real variable name that's being adjusted. If we go back to the friendly names, and we go back to loading and saving, you'll see now it says load the most recently loaded project at startup. Okay? Actually, maybe we will leave that on for the configuration part and then not during the coding part. But we'll just keep going here. You can restore your open assets on restart. I'm just going to uncheck everything. I just load nothing at start. Okay. Re-import directories. I'm not going to get into these. That's a little bit more on the advanced side once we get into assets and stuff. Enable autosave, save content. Check that. That actually becomes a default setting in future versions. They just don't have it defaulted here. And tool for diffing. You might want to change this if you don't have a Perforce installed and you want to use diffing tools. Although really it's not necessary because we're not going to be doing C++, so there isn't going to really be any diffing in this. Or ever on this project. Add new files when modified. Whether that would be added to source control, we're not going to do source control at all. In a future video at some point I would like to cover source control, but it's just out of the scope of this one. So let's move on to the miscellaneous section here. So here we get a cool combined translate rotate widget if you so choose. This one gives you, if you enable this, you get a fourth tool and you get a combined translate rotate, which can be kind of useful. So we're actually going to enable this one. Clicking BSP enables the brush. Yeah, we're not going to be using BSP stuff. Preserve actor scale replace. Yeah, we're not going to bother with any developer tool stuff. Although, one thing you might want to show is the show frame rate in memory. That will give you your editor frame rate. It shows up here. So we're running it around 120 frames with a little bit of drops. 4.0.2 has some like frame drops that they fixed in 4.1, but it's not important for what we're doing. Allow background audio and the enable editor sounds. You might want to allow background audio. The enable editor sounds is, so when we press play, it makes this like whoosh sound. And that's it. And they actually disabled it by default in the future. We're going to keep it disabled. We don't really need it there. Automation test is for unit testing stuff. We're not going to bother with that. Maybe another video. Experimental stuff, we don't really need anything in here either. Under the level editor, this gives you some like the opportunity to set your single window resolution and stuff like that. I'm gonna leave everything default for the moment, but if you want to change your resolution, feel free. The game is actually going to be at like an 800 by 600 4x3 units in Unreal space. So, but we might make it in a future video so that we can actually change the resolution and things like that too. That might be, you know, again, it depends how this video does and if people want more, or if it just ends up being a one-off or not. And finally, viewports. There's lots of options here just for changing how this viewport operates. And you'll see that the grid has disappeared. That's because we played and stopped. But if I lift the camera up, there it is again. It's just because we were literally perpendicular with the grid itself. Alright, let's start on the project settings here. So again, under Edit, we can go to the Project Settings. And again, we'll just drag that up here. So our company name, you make it whatever your name is. We're going to make mine Innadiated Games. We'll say it's, I don't know. I don't even have a website, so, you know, YouTube. /Innadiated. There's my website. And our support contact, we don't have one. Sorry, no support. Actually, just for completeness sake, because if you were doing a real project, you probably want that. I'll put my email. Alright. So, and then we've got our project description and stuff. This is a Pong clone for the purpose of learning about programming. And the project ID is what's called a GUID, a global unique identifier. And the purpose of it is so that Windows or other operating systems, but usually Windows, are able to identify future versions of the same software. So if you send out like a version 1.1 of your software, Windows doesn't think it's something different. It's like the same. And Unreal also uses that for identifying like whether or not it's the same project or a different project. So this ID lives with the project forever, even if we updated to like a different version. And if we were to generate a new ID or invalidate the ID, you know, it gets complicated. It's not really important. Just don't worry about it. Don't generate a new one. Whatever ID you have is fine. For the project name, we'll put Paddle War. And for the project version, we'll call this version 0.1. 0.0. I don't know. It's not version 1. Maybe version 1 will be in a future, because we're probably not going to do everything that I'd like to do with this in this video. I'd like to keep this pretty short and dirty. I don't have a copyright, but we'll just say it's copyright 2025 Innadiated Games, just for, again, completeness sake. Then you'd put your licensing terms and privacy policy, which would probably be like links and stuff. Alright. And under the Maps and Modes tab now, on the left-hand side, let's make our, you know what, we haven't actually created a map yet, so for the moment, we'll just leave this. Same thing with the default modes. In fact, you know what, we might not touch anything else in here until we've actually created some stuff. So let's close the project settings. And let's move on to actually talking about how we're going to build this. So how do we build a 2D Pong clone in a 3D engine? A 3D engine that's created things like BioShock and, of course, the Unreal Tournament games, Borderlands. You know, there's not a whole lot of Pong examples to go off here. So that's okay though, because a lot of people get confused about the difference between a 3D engine and a 2D engine. And there really isn't that big of a difference. The only difference is that a 3D engine has many 2D planes effectively. It's like a two-dimensional array, versus a one-dimensional array of 2D planes. And really what it comes down to is your camera a perspective camera or an orthographic camera? That's what gives you the 2D or the 3D view. The 2D or 3D look to it. And a perspective camera will give you these lines so that everything is pointing to the center and gives you that sort of real 3D look to it. However, a orthographic camera would have all of the lines remaining even as they went off into the distance. And so if you think of games like SimCity or Roller Coaster Tycoon, these are all orthographic games. But orthographic can also have like a top-down view where you're not looking at like an isometric 3D view. You're looking at a pure 2D view with layered sprites, or they can even be 3D models and stuff, and you wouldn't even know that they're 3D models. And that's effectively how we're going to make our Pong. Pong is going to be 3D, but the final result is going to look 2D. It's going to look very close to what we have in the actual, like screenshots of the actual Atari version of Pong. So I'm just going to set this up here. All right. So how do we start building that? I'll change this to type. I like type over here. And the first thing that we're actually going to drag in to the editor here is something called a static mesh. And all the static meshes that we're going to be using to create Pong are actually created right here in the engine. No starter content, no additional assets or anything is required. What we're going to do is we're going to go to this view options down at the bottom, and we're going to select show engine content. Okay, so now we have a new folder here called engine, and we're gonna select that. Now we could go through all these folders. There's lots of cool stuff in here that you get right inside the engine itself. But what we're going to do instead is we're going to go under filter, and we're going to select static mesh. And this is going to show all the static meshes inside the engine folder. And if you scroll down, these are all basically used to construct the editor itself. So they might end up being backgrounds or demo pieces, or like there's the actual camera that's used for the camera, right? So these are all, there's their little thing. They've got their cube for colors, and we've got a spline editor mesh here. So these all basically are meshes that they use to create the editor and create the engine itself. And one of them, actually two of them, are what we're going to use. So there's editor cube and an editor plane. And so let's drag editor plane in. And what you're going to get is that. So if you see this little rotation here, that's because we've have that additional tool, the rotate translate tool. We're going to select this one instead, just to keep it simple for now, which is the move tool or the translate tool. So what we're going to do is just center it. And the way that we're going to center it is if we go on the right hand side in the details plane, there's this location, which gives an X coordinate, a Y coordinate, and a Z coordinate. And if you hit this little yellow arrow here, it'll reset that to default. And it's going to disappear on us. Now, where did it go? Well, it's behind our camera now. And you'll see that it disappears depending on the angle of the camera. Now, to move around the viewport here, you can right-click your mouse and basically move like a first-person shooter. So, W is forward, S is back, D is, strafe right, A is strafe left, and then E is up and Q is down. You have to be holding your right mouse button while you do this, though. And as you can see, there's our plane, but our plane only has UV mapping on one side. So, or not UV mapping, but it only actually has surfaces on one side that are drawn, and the other side doesn't have any surfaces. So if you look at it from the other side, it's actually completely transparent. You don't see anything, but it's on this side, you can see it. And doing that, you can do lots of like transparency tricks and things in video games, but basically this is our default position here. And this is going to be where our camera is, and it's going to be looking at this plane, and this plane is going to serve as our sort of game board background, and we're going to texture it and make it look like the Pong game board a little bit later. But for the moment, I just wanted to drag it in and have it in our scene. Now, it's called Editor Plane. We're going to change the name of this, and we're going to call this Gameboard Background. Okay, so now we've got our Gameboard background there. And we're going to drag in one more. We're going to drag in this editor cube right here. So drag it into the scene, and it's actually quite large if you look at it. It's about the same size as our plane. These are, how large are they? They're 256 by 256 by 256 units, okay? And the plane is 0 because it's flat, so its X is 0 by 256 by 256. And this is going to become important when we decide to use these things and size them appropriately. So here's our cube. Same thing, we're going to reset its location to default. It's basically going to consume our plane. The plane is now inside the cube. Okay. And we know the size and everything, so we don't need the engine stuff anymore. So we're going to close this and go to View Options and uncheck Show Engine Content. We don't need it anymore. And we can go to our filter here and reset our filter. Alright. So now in our level, let's actually save this level. And we're going to go File, Save As. And inside our Paddle War content directory here, we're going to create a new folder, and we're going to call this Game Content. Inside Game Content, we're going to put a new folder, and this will be called Maps. And inside the maps, we're going to save our map, and we're just going to call this Paddle War Map 1. Why 1? The reason is that you might want to like experiment with maps, different layouts, things like that. And so often one strategy that's used is you'll have the name of the map and then a version 1, 2, 3, 4, whatever it might be. You know, and then at the end of the day, when you're actually putting the game together and deciding what map or whatever would go in that spot in the game, you might pick one of them or all of them, or, you know, who knows. But it just allows you to have variations and not say like one is definitively the one, you know. And then so we might do like different Pong layouts or things, or you might do different Pong layouts, because we're probably not going to do them in this video. But so that's what we're going to call it. So there we go. We've got Paddle War Map 1. We're going to save it there. Now in newer versions of Unreal, the maps actually show up in the content browser. In this version of Unreal, they don't. So if you wanted to reopen that level, you actually have to go File, Open Level, and select the UMap file to open it in the first place. Now what we're going to do now that we've saved our map is go to our project settings and go to Maps and Modes. We're going to set our game default map to be Paddle War Map 1. And our editor default to be Paddle War Map 1. And now we don't have to worry about whether or not our map is going to load on start. Same thing for the server default map. So if you select the drop down there, we might as well set that to be the same thing, since if you were to run a dedicated server, or if you wanted to implement multiplayer or something, you would want it to be the same map as well. So there we go. We've got our maps and modes set up, and so now every time that you open Unreal and every time you run the game, it's going to run our Paddle War map or Pong map, and it'll be fine that way. Alright, so we've got our cube, we've got our plane. Now we're actually going to duplicate this cube 2 more times. So what we're going to do is we're going to drag, hold Alt, left click, select the green arrow, which is the Y axis arrow, and drag it out this way. And you can set it over here. Select the editor cube again, hold Alt, and drag it out this way. So now we have 3 cubes, which is great. So one of them is going to be our ball for the game, and the other 2 are going to be our paddles. Now, in the original Pong, the ball was square, so we're going to, you know, we could use a cylinder, or we could use a sphere or something and make it look more ball-like, but I want to keep everything as close to the original Atari Pong as possible, and they used a square, so we're going to use a square. You can use a sphere or anything else if you would so choose, but do be mindful that the size of it is going to matter coming up here. So take note of the size the same way that we had taken note of the size of the plane and the cube. So let's select our middle one here, which is called Editor Cube, and we're going to call this Ball. Yeah, real simple, right? We'll select Editor Cube 2. We'll call this Paddle Right, because it's to the right side. We'll select Paddle 3. We're going to call this one Paddle Left, because it's on the left side. Okay. So that's pretty much all the assets that we're actually going to need to create Pong, believe it or not. It doesn't look like Pong yet, but it will. So let's play. Oh, it's all dark. Why is it all dark, I wonder? Well, the reason why is that 3D engines use lighting. And with lighting, you actually have to light your surfaces. However, we don't want lighting. We want that classic 2D look to it, right? So what we actually need to do is, you'll see in the top left of the editor here how it says unlit. Now if we change the editor to lit, It does have some ambient lighting, or it won't give us a lit because we have no lighting. So it gives us an unlit. What we need to do effectively is make our game an unlit game, not a lit game, so that we can see things even when there are no lighting in the level and everything is sort of like the color that it's meant to be, without any changes being done to it through lighting and shaders and things like that. So how would we create an unlit game? Well, where it actually happens is in something called a material. So the first thing that we're going to need to create is an unlit material so that we can see the things that we're working with. So under our game folder here in content, we're going to create a new folder. And we're going to call this folder this should be game content as well. Or sorry, let's do share content. Yeah. Because these are going to be generic materials that you could use in any game. We're going to do shared content. We'll actually create our game content folder here too. And this is going to have a folder in it called maps, which will map to where our folder for the map was, just for completeness sake. So under shared content here, we're going to create another new folder. We're going to call this materials. And under this folder, this will actually be where we create our first material here. Actually, you know what? No, let's do one more folder. We're going to call this basic colors. Okay. So in basic colors now, let's right click over here in the content area and create a new material. And we're going to call this material capital M underscore basic color master. Okay. Let's double click that. And what we're going to get is an editor that looks like this. And this is the Unreal Material Editor. We'll drag it up here so we get a full screen view. Now, I'm not going to get too deep into how materials work yet, as we just need some simplified stuff to set up colors, and that's really just going to be our base color. But it's not actually the base color. What we actually need is an emissive color. But we're going to create a master material that can actually do lit or unlit colors. And some other basic stuff here so that we can actually set things. But so what we're going to do is, this is our result thing. So the default base color is black, as you can see. It's 0, 0, 0. If you were dealing with like hexadecimal, it's completely black. So what we want to do is make the color configurable of this material. So what we're going to do is drag off this base color, and you're going to get this little line. You can drag it around like this. And when you release, you're going to get a menu like this. And these are all the different sort of things that you can do with this base color. What we're going to do is type parameter. Actually, you can just type param and it'll be good enough. And what we're going to do is get a whole list of parameters here of all the different stuff that we can change. And for this type of parameter, a color is actually a vector parameter. Now, a vector is a value that has 3 values, or sometimes 4, but it's basically a collection of values. And they're used for all sorts of different things, direction and colors, and in game programming, vectors are very prevalent, so we're going to see them a lot. And this is our vector parameter. And as you can see, the default value is 0, 0, 0, 0. And all of those values are pumped into this white one here, or you can access them individually from here. So our red value is here, which is 0. Our green value is here, which is 0. Our blue value is here, which is 0. And this fourth one is something called alpha. And that basically is sort of an arbitrary value that defines transparency. But you can use alpha to add in extra data that can mean all sorts of things. It doesn't always necessarily mean transparency. Sometimes it's just useful to have another channel when you're packing textures and stuff. Again, another advanced concept, we'll get into that in the future. If we do. But so this parameter, what we're going to call, we're just going to like literally mimic the parameter names of the material, because we're just creating basically just a front end to this. We're not going to do anything fancy in the graph for this basic color master material. And under the group, we can call it just base color. Actually, we'll just make the group base, just to make it easy. So yeah, and the default value of 0 is exactly right. We want to use the same default values that they have here for our parameter defaults, so that a default material is still exactly a default material. And we can put a description in if we want. We could say the base color parameter. I mean, I'm not going to get too, you know, and then it shows you up there, which is very nice. Okay, there's our base color parameter. We're going to do the same thing for metallic. So we're going to type param. For parameter, or for metallic though, the type of parameter we need is a scalar parameter. And a scalar parameter is basically just a single value instead of a collection of 4 values. We're going to call this metallic. And we'll set the group to base as well. And our default value, I believe, is 0 on metallic. Yeah, I'm pretty sure. So the metallic parameter, okay, sits under there. You can move these around and sort of organize them however you'd like. Specular, same thing. So we're gonna drag off this and set a scalar parameter. We'll call this specular. If you are not too familiar with the way lighting in 3D engines and stuff works, you'll see that our specular has a default value of 0, our parameter does anyway, and our black circle has basically blended into the black completely, and that's because there's no reflections now coming off of the surface. We're going to set this to base, and we will set the default value on this one to 0.5, which is the default that they give you, which gives you like half reflection basically of a light source. It's not reflection, but it's light reflection. Alright, so now let's take a look at the roughness value. Now roughness is kind of like similar to specular, but this is what controls sort of like how reflective or how smooth a surface is. So we're going to set this to a scalar parameter once again. Call this roughness. we can set a description on the specular. We can do that. Just to make them all the same. Alright. Put our roughness there. And the roughness, I believe, has a default of 0.5 as well. Looks about right. And we'll set it to base, and we'll say this is the roughness parameter. And finally, emissive. We're not going to default normal, world position offset, or ambient occlusion for this tutorial, because this material, because this material is entirely just about basic colors and pretty much just HTML colors, right? Sorry, which one? Oh yeah, emissive color. So this one is, once again, because it's a color, it's going to be a vector parameter. You can just put that there. There's our vector parameter, and this will be emissive color. And we'll keep it a default of 0000 as well, which is black. And we'll set it to the base, and we'll say the emissive color parameter. Alright. So there's our parameters, and as you can see, our material has not changed. It looks exactly the same. And that is by design. So that is all we need to do in this one here, the master. So we're going to save it, and we're going to close that material editor. And you'll see we now have the master material right here, ready to go. Alright, now that we have our basic color master material, we can start creating some actual colors. So what we're going to do is follow the HTML color naming code just to make things simple. So if I go over here to the HTML color names, you can see we get a bunch of different colors and the name that's associated with the official code, and these are like the codes that are associated in browsers, and you can use names and stuff and it translates it to a color code. And for the basic colors, I like doing it this way, as then we can get names and everything works out properly, instead of just sort of picking from a color wheel and picking a name and being like, oh, that's green, or that's red, or that's dark red. It gives some sort of like standardization to it. So the colors that we're going to actually use for this are going to be black, which is obviously our default color there, and dark gray, and we'll use white as well, which is all Fs. So we'll create those colors now, and the way that we're going to create these colors is we're going to create a new folder inside our basic colors folder, and we will call this one lit, and we'll create another folder. We'll call this one unlit, and what we're going to do is right click on our basic color master material here and create a material instance. And so a material instance is basically, like, you can think of the material itself as a template, and then the parameters that you expose, and along with some default parameters, can be changed in the instance. So we're going to name this instance mi for material instance underscore basic color black. So black will be the first color that we do, because we already effectively have black. So no real change actually needs to be made to this material instance. All of the default values are exactly what we want for this. Actually, sorry, let's rename this one more time. Let's add black lit. Or let's make it lit black. So basic color lit black. Okay, and now that we have that, we can move it into the lit folder here. There we go. And we're going to do it one more time. We're going to create a material instance. We'll call this mi basic color unlit black. Now obviously, oh, what happened there? Autosave came in and whacked it. Sorry. So mi underscore basic color unlit black. There we go. And we will move that one into the unlit folder. So first let's deal with the lit colors, as they're easier, as lit is the default. We will right click the black one and create another material instance. We'll call this one mi basic color lit dark gray. And we can go into this dark gray one here. And as you can see, we get the view is a little bit different. There's no graph. And what we actually just get is our options and everything that we expose. So the material overrides is our base properties. And then the parameter groups is the stuff that we set up in the material itself. So here's all of our different parameter groups. We can change base color, and we're going to set base color. Now if we go over to our setup here, maybe we'll use gray. Now we'll use dark gray. Dark gray is fine, because gray is actually darker than dark gray, as you can see. So dark gray is actually like gray. They should probably switch that, but it is what it is now. So we want to set the base color to that, so we can click the color here. We'll get a color wheel, and if we drop down advanced, we'll get this hex code here, and we can enter our hex code. Now we also need to add a alpha value, and the alpha value is going to be FF. Sorry, I think it's actually alpha first. Now let's see what this does actually. Yeah, FF. So it's alpha less. Okay. So there's our dark gray. And that's all we really need to do for this one. So we can save it. And we'll do one more, and this one will be white. And the reason we're creating lit materials as well as the unlit materials is this is just sort of for your convenience, so you can use these if you want in lit environments. It just makes it a more complete package. That's why they're under the shared content. Basically, the stuff that's under shared content is stuff that could be easily exported to any other project. So we'll call this one white. And open it up. Change our base color, and white is just all ones basically. And that's going to be white. Now there is one change that we should be making to the black one, and that's to give it an alpha. So let's actually override the base color on black and give it a alpha value of 1. We'll save that. So that's our dark gray, that's our white, that's our black. So now we're going to do the same thing for the unlit materials. But first what we need to do is actually make this material an unlit material. So let's double click it, we'll go in here. We have our same sort of setup here. So the first thing we'll do is override the base color. We'll set the alpha to 1 just like the other one. The next thing we're going to do is go down to this material overrides and we're going to override base properties. Nothing's changed so far, but it did reload here. Now, in this base properties, we can actually adjust a variety of things, such as the lighting model. So we're going to change the lighting model, and we're going to make this material unlit. And as you can see, it basically disappears because now it's black on black, which gives you black, obviously. So we'll save that. And that is now a black unlit material. As you can see, it's sort of lost its shading and now it's just a black circle. You can't even tell that it's a sphere anymore because it has no lighting. So let's create a new material instance based on that. We will call this one basic color unlit dark gray. Can open this up. And once again, we will grab our dark gray color value here and we'll stick it in base color. Just like that. And there we go, dark gray. Oh, except it's not base color. So, okay. So, it's actually the emissive color because it's an unlit material. And I'll get into why that is at some other point here. But so what we actually need to do is set the alpha to 1 on the emissive. So that's our black set properly, even though it doesn't really make a difference with black because there is no light coming from a black surface. But what we're going to do is make this our gray. There it is. That's much nicer. And we'll uncheck the base color there. We don't actually need the base color. And we no longer need to override the base properties because it's inheriting from our black unlit material. Even though the lighting model there says default lit, that's not correct. It's actually getting the unlit from here. So let's create a new material instance based on our unlit black. And we will call this one basic color unlit white. And same deal, we'll take our emissive color here and we'll just make it all ones to be white. And there it is. And you can see the difference between the two colors a lot clearer on the unlit materials versus the lit ones. Alright, so let's save all content here. There we go. So now that we have these materials, we'll be able to see these in the world. And to prove that's true, let's go ahead, and the first thing we're going to do is assign our Gameboard background. If we go up here, Gameboard background, under materials, there's this element 0 and it's set to none right now. Let's go ahead and we can type unlit in the filter and we'll get our 3 unlit materials. Let's set that the game board background for now to dark gray. Just it will be black, but we're actually going to do a custom material for the game board a little bit later on. This is just sort of to differentiate it. And we can select our paddle right, and we're going to go to materials, element 0, and we're going to select, actually let's type in here unlit, make sure we get the right one. So unlit white, you'll see it turned white. We'll do the same thing with the ball. There's our unlit white. And we will do the same thing with the other paddle, unlit white. So now if we play, we're still inside, but you'll see that we can now zoom the camera and actually see things in the world, and we even collide with them. These things even have collision, which is going to be extremely useful for us later on. Alright, let's just reset the camera. You have black screen, but that's okay. That's zoom out a bit. Alright, let's just get things sort of sized properly, okay? So what we're going to do is we can close all these things and make it nice and neat. And then we'll select our game board background. Now, earlier I had said that we're going to make our game board sort of fit 800 by 600 resolution. I mean, it's not, we'll be able to pick any resolution, but the amount of units that will actually comprise the game board is going to be 800 by 600 for a sort of 4x3 look, and then maybe in a future video I'll show how to adjust it based on the resolution. But to start with, we'll start with 800 by 600 background. And so to set the background, because it's a model, there isn't really a like set size. So the model has a size, and if you remember, that size is 200 or 0 on the x-axis by 256 on the y-axis by 256 on the z-axis. Now, models do have a scale, and so the scale is basically a multiplier on the actual size of the model. So for instance, if I give the plane a scale of 1 in x, because x is 0, so the value in x is always going to be 0 regardless what the scale is, because 1 times 0 is 0, and so is 10 times 0. But we put a scale of 2 in y and a scale of 2 in z, you'll see that it now pops up and has gotten twice as large as it was before. Now, that's helpful, but it doesn't really allow us to set a specific size if we want, say, 800 by 600. So we're going to have to figure that math out on our own. And it's actually not that difficult to figure out. All we have to do, let me get my calculator here so everyone can see. So we've got the calculator here. So all we have to do is take our target size and divide it by the actual size. And that's going to give us our scale. So for a width of 800, which is going to be what the y scale is, we're going to take 800 and we're going to divide it by 256. And that's going to give us a value of 3.125. So this value, 3.125, is going to go into X, or Y, sorry. Alright. The next value is 600, and we're going to again divide that by 256. That gives us a value of hold on. Yeah, let's just copy this whole thing. 2.34375. I just want to make sure I get it in there right. Copy paste is your friend. So there we go. That's it's 800 by 600 Unreal units. Exactly. So that's how you can sort of scale models to an exact size. Now, it only really works with like square models or uniformly sized models. You know, if you have stuff that's weirdly sized, then it gets a little bit more complicated. But for the most part, that's how you do it. So that's the size of our background. We're going to set the location to be plus 100 units on the x-axis, which is going to send it sort of further back. Okay, so now if you look, it's almost outside the cubes because the cubes are 256 units and this is sitting at 100 on the x-axis, and negative 100 would be on this side, and that would almost, you know, like that's 200 units, but the cubes are 256, so there's still 56 more units. And so we can assume that the amount of units that's sitting here on the other side of there is, or what, 28? Yeah, 28 units. That would be what's sitting here, would be 28 units. All right, so there's our background. Now the ball, if you look on the original Pong screenshot, the ball is maybe like 4x4, like probably less. It's probably like 2x2 pixels because they weren't working with very many pixels back then. What we're probably looking at for a ball size is probably something like 4x4 or maybe 8x8. Let's go with 8x8. So what we're going to do is resize the ball to 8x8x8, but not the scale. What we're going to actually do is take 8 and divide it by 256. And that's going to give us this for a scale. We're going to take that, and we're going to put that into each one. And there we go. We now have a very, 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 very tiny ball, as you can see. It's still a cube, although it's hard to see with the other cubes around. Okay. Still a cube. All right. So now for the paddles, let's select these here, and what we want is we probably want like 8 as well. So for like the width of the paddle, 8 is probably a good value. So we can actually take that one that we used for the balls, for the width of the ball, and we'll make the width of the paddle the same thing. And we can probably do the same thing for X as well, given that it's going to be 2D anyway. So having it the exact same sort of depth as the ball makes sense. And finally, we need the height. And a good value for height of these paddles is probably something like, say, 40 units. So let's try that. We'll put 40 divided by 256, and that's going to give us a value of 0.15625, and that's going to be what we throw in the Z. And by the way, to select both of those at the same time, just select one, hold shift, or sorry, select one, hold control, and then select the other one. If you hold shift, it'll sort of select in a group. And that allows you to assign common parameters. So you'll see I have them both paddles selected, and they have different Y coordinates, but their X coordinate is exactly the same, and so it's shown there. Its Z coordinate is exactly the same, and so it's shown there. And we can see that the scales are the same for both paddles. Okay, one more thing. So we're going to select the paddle, the ball, and the other paddle, and we're going to change their mobility here to movable. And that's more or less what our game board is going to look like, our starting game board here. This gives you an idea. Now we are going to replace these with pawns and stuff like that. We're going to kind of do, a bit more than this, but this is just to get the initial setup going, just so we have the visuals. And then once we have the visuals, we'll be able to focus on code, and it'll just be pure code from then on out. And the visuals don't take very much, as you can see. So there we go. We've got our Pong board set up. Now we might want to actually choose a different location for where these paddles actually are. You can see that they're at what is that, -280. What we're gonna make it is actually -350, and that's gonna put it basically 50 units away from the edge, because if you remember, our width is 800 total, which means each side has 400. So from 0, which is in the center, -400 is the edge. So we are placing our paddle at -350, so that there is a little bit of room here on the game board after the paddle, okay? And we're going to do the same thing with the other paddle, except this one, the right paddle, we're going to do it +350 because it has to go the other way. So there we go. We've got +350. We have something like this. And as you can see, we can now see everything, even though we're playing the game, and even though there's, things are lit, you can actually tell that things are still lit because there's exposure effects, and there's this glow. You see the glow coming off the paddles. That's because we're still using lighting effects, exposure and stuff like that. So we will turn all that stuff off so that we get a pure experience, classic experience, one that isn't disturbed by 3D lighting. But it is interesting to see that there. Now, there's one more thing that I want to do before we move on to a little bit of code. And if we select this right paddle, you'll see that the direction of X is facing towards the background, and that's because X goes off into the distance that way, and that's sort of our forward vector. But each individual object also has its own forward vector, which by default is going to be the world forward vector. Now if we go up here, so this is the toggle between world and local space. So right now it's on world space, so all of these coordinates are aligned to the world, so they're all facing the same direction, you see. However, if we switch to local space, now they're all still switching or facing the same direction. However, if we select the rotate tool and rotate this paddle, and we're going to rotate it on the blue one 90 degrees that way. And now if we go back to the transform, you'll see red is facing that way. So forward is now that way for this paddle. However, if we switch back to, let me get a good angle here, switch back to world space, you'll see forward is still this way. So locally, this paddle's rotation now ensures that forward is facing this way, which is facing towards the game board. And that's called the forward vector. And this is going to be something that's very useful for us to use when it comes to hit detection and deflections and stuff like that. So it's something that we're going to use, so we're sort of setting it up now. And we're going to do the same thing with the paddle on the left side. So let's go over here and we'll get the rotation. And this time we're going to rotate it the other direction. We're going to go clockwise so that red is facing this way. And now that is the forward vector of that paddle. And finally, the ball, we're going to do the same thing for, although the ball will be programmatically altered regarding its forward direction. But just for display sake, we're going to do this in our setup here as well. And so we're going to do clockwise as well. And now the ball's forward direction is positive on the y-axis. So this is positive, this is negative, and we have the ball's sort of starting forward vector positive on the y-axis. Now, when we actually set this game in motion, where the ball spawns and what direction it's facing will actually be randomized. But until we actually get there, it's best to just keep things nicely aligned. And then finally we have our background. As you can see, our background's forward direction is also locally in the correct position. It really doesn't matter. We can go back to the world axis now. Make sure you do that, as you don't necessarily want to be always altering the local when you're moving things around. Alright. So now that that's done, let's get started and build the actual game. So we're going to go into game and then game content. And we're going to create a new folder here, and we're going to call this blueprints. Now blueprint is a language that is unique to Unreal, and it's a visual language, and it's the primary reason why I've kind of chosen Unreal as a platform to do this in, as I think that it is a better tool for explaining code and explaining what things actually are, because you get a nice visual representation. So we get a nice visual game, we get something fun to play, and the code is also represented visually, and I think that really helps a lot. I think, I really wish that there had been something like that when I was learning to code when I was younger. So within our blueprints directory here, we're going to right click and we're going to create a blueprint. And this blueprint is going to be a game mode. So select game mode, and what we're going to call this is BP for blueprint underscore. We'll call this the Paddle War game mode. Just like that. And now that we have our game mode, we'll set these things up in a moment here. We can save all, just save it. But the first thing that we're actually going to do now that we have the game mode is go to project settings and maps and modes. And this drop down here, the default game mode, we're going to now change it to our Paddle War game mode. And we will do the same thing for the global default server game mode as well. Because again, maybe at some point I'll do a multiplayer in the future. Alright, so now that that's set up, we'll be able to do a few more things with working with it. I'll kind of get into what that did a little bit later. Let's go up here to this blueprints and see this open level blueprint. Let's open that. And that's going to open the blueprint editor. And as you can see, we get this welcome to blueprints, another tutorial. You can just sort of click through this or read it, or it's going to go through, show you the UI just like the other one did, and then we can complete it. Okay, so let's go up here, we'll drag it up there, and there's this here, blueprint properties. We're going to open up that. And this allows us to put like a nice little description and do things like generate a cons class. It's a good thing to know about, and we'll be opening this for basically every blueprint when we set them up. So the level blueprint, we're just going to say that this is a map for paddle war gameplay. Something like that. Just give it a nice description. We can close that one, and we're going to open up this one, and we're going to, I don't know, I guess get the same tutorial. Why did it do that? Alright, hopefully it doesn't open every time. We can pull that up here. So this is, again, we can pull up our blueprint props here. Now, because this is a blueprint, not just a level actor, we get a few more things. So we get this run construction script on drag. Well, this is a game mode, which isn't going to be dragged in our level, so we can actually uncheck that. Generate a const class. We can actually probably check that, but I'm going to leave it for now, and we'll just, because I don't want to explain what this means yet. And then for the blueprint description, we'll just say the base game mode for Paddle War. Okay. Descriptions don't have to be fancy. They're just nice because they show up in the UI. So when you're sort of like mouse overing different objects and things that you see, if you don't fill in descriptions, you're not going to see anything useful about them. And so putting a description just gives you a nice sort of overview of whatever it is, even if it feels a little redundant. Alright. So now that we have our blueprint props, we can get started with our graph. So the graph, there's a blueprint defaults here. Let's go to that first, and you'll see that we have some stuff that we can set up, and that's our default pawn, a HUD class, a player controller class, a spectator class, a game state class, and a player state class. So what do all of these do? Well, the default pawn is like the default character or something that spawns when a player joins a game. We're actually going to set this. Can we set it to none? I don't know if we can set it to none. I was going to set it to none, but I guess we can't. So we're going to have a default pawn, and we'll just destroy that pawn in code. The HUD class is a special blueprint that basically controls any on-screen displays or stuff like that. And it's actually a very useful class for connecting a player and a player controller, so that you always have sort of a centralized place that has a player controller associated with it to instruct things from. The player controller is the actual interface. So when you press a key on the keyboard, or move the joystick or something, it'll go to the player controller, and then the player controller will tell whatever it's controlling what to do. Now there is also an AI controller which we will be using, which is going to allow you, which basically acts just like a player controller, and except instead of like reading keyboard inputs, it scans the game and simulates inputs of various types, and can basically control different things in the same way that a player controller does. And so that way they're interchangeable. Like anything that a player can control, AI can control, and vice versa. Spectator pawn we're not going to get into. It has to do with multiplayer. And then we have the game state and the player state. And basically, because the game mode is a server-side sort of like read-only class, the game state and the player state are actually what are transmitted to different clients and contain the game state and the player state. So basically your save game data is this stuff. But not exactly, because in Unreal, if you want to actually make a save game, that's another call. You have to create an actual save game. But in terms of like server state, like the actual like save data that's actually happening at the moment and getting sent to clients in a multiplayer game, or a single player game can be too, that's what these are. Now, we don't have any of these yet, so we're not going to set any of these yet. Then we have the graph, and the graph is basically where you would do code. But in our game mode, we're actually probably not going to be doing a whole lot of code. The main reason to have a custom game mode is so you can set these things. Okay, so now we have our game mode. So the first thing that we probably want to make is some sort of like a pawn, so that we can actually have the player control the paddles, and so that the ball can move. So all three of them are actually going to be pawns, although the ball doesn't actually have to be a pawn. We could just leave it as an actor. Maybe we will. But the paddles are going to be pawns, because what we're actually going to do with the player controller or the AI controller is tie it directly to the paddles. And with the AI controller, when the game starts, we'll actually have an AI controller on both paddles, and so the game will start playing on its own, and the AI will fight each other until you press a key like spacebar or something, and then at that point you will take over the left paddle and fight the AI in a new game, a new round. So that's what we're going to aim to build. So the first thing we should do to actually build that would be to create our paddle pawn. So inside Blueprints, we're going to create a new folder here. We're going to call this Pawns. And we'll create a new blueprint of type pawn. And we're going to call this paddle pawn. Okay. Drag this up here. We'll go to our blueprint properties. Now this is something that is going to be draggable. So we'll leave that checked. And for the description, we're going to put implements a simple Pong-like paddle. Okay, as you can see, the parent class is set to pawn. That's great. Interfaces, we probably won't cover interfaces in this, but they're a thing. Alright, so there we have our pawn set up. So now what we're going to do is actually replace these two pawns with our new pawn. And so let's go ahead and select paddle right, or paddle left, sorry. And we'll right click it. And then they have this replace selected actors with. And we can actually go through here. Maybe if I have it selected, it'll work better. Ah, here we go. That's what I wanted. See, replace selected actors with, and the BP paddle pawn is selected. So we're actually gonna do that, replace it. Now our cube disappeared, and that's because we swapped out the actor type. So we no longer are using the editor cube static mesh actor. We're now using our own custom paddle pawn actor. Go to our paddle right here, and we're going to do the same thing. We're going to replace with our BP paddle pawn. So now both of our cubes have disappeared, but don't worry, we'll be bringing them back. And the way that we're going to bring them back is if we open this BP paddle pawn, we get sent to the defaults over here. We're going to actually go over to the components tab. And we get sort of what looks like a level editor. It's very similar to what the main editor window is, except this is an editor specific to our pawn. And everything is local to this pawn. So what we're going to do is we're going to add a component to this pawn. And we're going to add a static mesh component. We can rename this, and we're going to call it paddle mesh. So we'll just make a category that's effectively the game, right? Like, so we'll just put all the game stuff under a paddle war category, like that. Okay, so the transform of the mesh, we want it to be like the same, basically default. The mobility is going to be movable. And here is where we select our static mesh. Now, we're going to have to once again show engine content in this dropdown and just type in cube. And you should once again get the editor cube. There he is there. And finally, we need to associate a material. So under rendering, we have this materials. We're going to add an element. And for element 0, we can uncheck show engine content now. And once again, we'll do our unlit white. There it is. And under lighting, we can uncheck cast shadow and all of this stuff too, just to bring some of the, potential performance. Can be character based, no. Under rendering, it's not going to be receiving decals, so we can uncheck that. And this collision preset sets the object type to be a world dynamic object, which is one of the types down here. So you'll see world dynamic blocks. So a world dynamic is the type of this object, and then the type of collision, the collision enabled, works against these channels. So you can either do one of these presets here, or you can do a custom setup. We'll just be leaving the block all dynamic because it is the only thing that it's going to block is the ball, and the ball is also dynamic. And in fact, we're not even going to block the ball. In the end, we're actually going to use overlaps. So we can enable gravity, even though we're not going to have physics enabled. So once we're done there, we're going to hit this compile at the top and save. And you'll see we now have our paddles back in the scene. And if we hit the local, they should still be facing the correct direction. Okay, so that is our pawn for the paddle. Now we just want an actor for the ball. But we're not going to use the static mesh actor that Unreal uses by default when you drag it into the scene. Instead, we're going to create a new actor that's our own thing. And so we're going to call this folder Actors. And inside here, we're going to create a new actor. And this will be BP for blueprint underscore ball. Can open this up, go to our blueprint properties, leave the run on drag. We can throw a simple description in here, implements a Pong style ball. Typoed style. Okay, we can save that. And if we go to the Components tab, we're going to do the same thing. So we're going to add a static mesh component. We'll rename this to Ball Mesh. It'll be movable. We can select our let's make this bigger maybe. Can select our editor cube here. We will leave the overlap or generate overlap events. And this is going to be a overlap all dynamic. Add a material. We'll add our unlit white. And I'll deselect the show engine content there, get it out. Once again, can remove the receives decals. Can remove the cast shadow and remove all this other lighting stuff. Cannot be used as a character base. All right. And there's our cube. That's our ball. And as you can see, we now have replaced everything, and it's exactly as it was before, only now it's using our own custom blueprints to do it. And that's going to become important because that's where we're going to put our code to actually make these things do something. Let's go back to the blueprints folder, and now we're going to create our player controller class. So let's create a new blueprint. We'll make a player controller. This will be BP Paddle War Player Controller. Go to our blueprint properties. We are going to uncheck the drag, as player controllers are not an actor which shows up in the world. And for the description, we will put handles player input. It's real simple. Press save. There's nothing else that we really need to do in this one yet. We will do more here. This is still just sort of getting our base infrastructure set up. Alright, I think that's good. So let's open the game mode. Oh, we need the HUD still. actually. The HUD is a class we do need. So let's once again right click, new blueprint in the blueprints folder here. And HUD is not here yet. They do add it later, I believe, but we'll go to custom classes and just type HUD. And we'll select HUD here and go like that. We're going to go BP, Paddle, War, HUD. Open this one up. And same thing, we'll set our properties, we'll uncheck the drag because HUDs are not a level actor. We'll just say simple HUD for Paddle War. Alright, now we got our HUD and we can open up our game mode here. And we're going to set our pawn, our default pawn. Actually, we'll leave default pawn as default pawn because we're going to reattach controllers to pawns, so we're not going to actually use the pawn that it spawns. We're going to use the one that's already existing in the world. For our HUD class, we're going to change this to the Paddle War HUD. For player controller, we're going to change this to our Paddle War player controller. And for now, we'll leave the rest of them. We'll probably look at game state and player state, although I'm not 100% sure if we'll actually use those. So the first bit of code that we need to do is to set up our game camera and the orthogonal display. And that will make it look like Pong, basically. And so the way that we're going to do that is if we go up here to this all classes and select that and scroll down, you'll find this camera. We're going to drag the camera into the scene. Let's default its position, and then we will set its X position to -100, bringing it closer to us by 100. So now if we look at our setup here, you'll see the camera is 100 over here. The gameplay itself actually sits right on the Y axis, and then the background is 100 units behind the gameplay. So our camera is now staring directly at the ball, effectively. You can see it there. But we're going to make some adjustments. So we're going to call this the Paddle War camera. Actually, we could just call it camera. We're not going to have any more of them. Okay, our location and everything here is fine. Now this is where it gets interesting. So we're going to change this from perspective to orthographic, and this is going to go all black on us, don't worry about that. And then for our ortho width, we're going to set the width to 800. We'll keep the constrained aspect ratio, and for the aspect ratio, if you select this drop down here, you'll see a bunch of different resolutions, but you'll notice that the aspect ratio for resolutions of the same ratio, the same aspect ratio, are all the same. So like 1024 by 768 is the exact same as 640 by 480. So we can just pick 640 by 480, and that will give us the proper aspect ratio. And then our ortho width of 800 will give us a 800 by 600 resolution. And then the game engine will scale that up based on what our actual resolution is, but it'll be 800 by 600 units regardless of the resolution, with black bars added because of the constrained aspect ratio. Okay, does that make sense? So the camera's sitting in our world, but we're not actually doing anything with it yet. So let's go ahead and let's go to blueprints, and we're going to actually open the level blueprint here. Yeah, we'll do it from the level blueprint. Once again, it's giving me the tutorial. I'm not really sure why it's doing that every time I open up a blueprint, but it is. So this is the blueprint editor, this big graph thing here. We'll save our level. And so what we're going to add to this area here is we're going to add a event begin play. And the way that you do that is you just right click. You can do a search, type begin play, and you'll get an event begin play. You can select that, you'll get a little node like this sitting on the screen. And this is the entry point, and this runs every time that you start play. And if you want to prove that, you can just drag off the little arrow, which is the execution node, and we're going to type print string. We'll put print string here. So now every time event begin play runs, it's going to print a string. The string is hello, which is fine. And if you click the little drop down here, let's uncheck print to log, as that's not necessary. You can change the color if you like. The print to screen, leave that on. We'll compile this blueprint by going to the top left corner and hitting compile. Save. And now let's hit play. And you'll see when we play, we get a hello in the corner. And if you play again, you'll get it again. So this is executing every time that we press play. And that's why it's called begin play. So we can leave that there. We'll delete the print string. And now what we're going to do is right click here and type controller, and there is this get player controller. So this is going to get a reference to the current player controller, which, if you remember, in game mode we set that to the player controller that we made, Paddle War player controller. So now that we have our player controller, you see there's this player index and it takes a value. Now, this is deceiving because usually the only player that you're interested in is index 0, unless you're working with a split screen setup. If you're working with a split screen setup, multiple players will have a different index. So your player 2 would be like player index 1. It is not true for multiplayer setups, so like network multiplayer. So if you're running a network server, each client has their own index of players that are active on that client. And if there's only one player active playing on that client, there will be player index 0. So we can leave this 0 hard coded here, although there are ways that you can structure your application or structure your setup so that you don't have to make assumptions. And that ties back to the HUD object that I was talking about earlier, but for this one aspect, because we dumped the camera directly into the level, it's easier to do it from the level blueprint, and we'll just make the assumption that the player is player index 0. So with that being said, let's drag off the return value, and this is going to be, the return value is going to be an actual instance, a running instance of our player controller. Now, when we drag off here and let go, we get another menu. And in here, we're going to type pawn. And we get this get controlled pawn. So a player controller has a pawn that it associates with, and this is going to give us a reference to that pawn specifically. Let's drag off this, and we're going to go to this, promote to variable. And that's going to create a new variable on the side here. And so we're going to name this variable player pawn. Pretty simple. Down here in the details, we're going to set a few of these things. For the tooltip, we're going to say that this contains an instance of the default player pawn. We're going to set this to be a private variable. Now, what is a variable? A variable is something that you can use in your scripts or your code here to store information. So what we're doing here is we're getting the player controller, we're getting the controlled pawn up from the player controller and storing it in a variable called player pawn, which holds a type of pawn. You see the variable type there holds pawn. So we can take any pawn and stick it into this variable, but we're going to use it to hold the default player pawn, and I'll show you why in a second. Under category, we can again put paddle war and then a pipe. The pipe symbol is usually located above the enter key. It kind of looks like a 1 or an L, but it's a little bit longer. And the pipe symbol in a category gives you this sort of unique ability to create subcategories. So a Paddle War pipe game will now create a Paddle War and game category on our side here. The pipe symbol I use often in my video titles, so if you're not sure what it's supposed to look like, you can find it in my video titles. Let's go ahead and compile that. And we're going to drag this execution from begin play into there. And so we're going to set player pawn. That's the very first thing that we're going to do. And what is it getting set to? Remember how I said that the game mode has this default pawn? That's what it's going to get set to, is this class right here, this actor, this pawn of type default pawn, which is not the one that we want. So we're going to store it here because we're going to actually do a little bit of work on it and then delete it. Alright, so the next thing we're going to do, dragging again off the player controller here, we're going to type detach, or sorry, maybe it's off the pawn actually. Yeah, drag off the pawn. Yeah, okay. And you see the pawn has this detach from controller pending destroy. We're going to do that. So that's going to detach it from this controller. So after this executes, get controlled pawn is no longer going to work from a controller. So if I take this and stick it over here and do, say, this whole thing again, this will actually get set to a null value. It'll be nothing because there is no controlled pawn after this executes. And that is why we are storing it here ahead of time before we detach it, because once we detach it, we sort of lose access to it and we can no longer find it. But now that we have it stored, we can actually find it. And we could actually, instead of dragging off this get controlled pawn, we can actually use our variable here instead. And so what we're going to do, if you hold Alt and click, it'll detach the wire. And we'll put our variable there instead. And why use the variable instead? Well, because we've already taken the time to store it. So we don't really need to call these two functions again. If we do this, code is going to execute to figure out what that pawn is and then return it. If we use the variable, no code really has to execute except for storage and retrieval code, basically, which is a lot lighter. So it's an efficiency thing here, using the variable. Though this would be perfectly valid too. You could do this. Alright, so now that we've detached it, what we're going to do is we're going to actually take this pawn variable and duplicate it again. To duplicate, it is Control plus W. We're going to drag off this and we're going to type destroy. Now you're going to get this destroy actor. We're going to do that. So now that actor is destroyed and this variable will contain nothing. And the reason that we needed the variable was so that we can first detach it, and then after it's detached, get a reference to it again to destroy it. This is the only way that we're going to be able to get a reference to it again, unless we had it stored or attached to something else. Okay, so now that we've done that, we can do our activation of the camera. So we're going to go back over here to our map, select camera, go back to our blueprint and right click, and you're now going to have this add reference to camera. We're going to do that. And dragging off that, we're going to type view. Yeah, set view with blend. Maybe I'll drag off the player controller. Yeah, okay. Okay, so let's actually duplicate get player controller as well. So if you select get player controller, hit Control W, you'll get another one. We're going to put that over here. And we'll put our camera over here too. Dragging off the get player controller, type view, you're going to get this set view target with blend. We can connect the execution after the destroy. Now the new view target is going to be our camera object. A blend time of 0 is fine. This is if you wanted to do like camera switch animations and stuff. The style is fine because it really doesn't matter if you have no time. Same with the exponent, and the lock outgoing doesn't matter either. So all of these can be left default, and we'll just sort of bring this in a little bit closer like that. So that's our code so far. So first we set our player pawn, we detach from the controller, destroy it, then we set a new view target because the view target that is created by default is no longer what we want. We want to use our camera and our settings. And that's it. Now we'll be using the camera. So if we go now and press play, you'll see it perfectly fits the screen. We have black bars and it's 2D. You couldn't tell that that's 3D. As well, if you go in, you can no longer move the camera around like you could originally when you played. It is now static and stuck there. And that's it. That's our setup of getting our camera working. Now, you might be wondering, why do we need to destroy that pawn? Why don't we just leave it? Well, that's a good question, and I'll show you why. So let's take this execution pin and plug it directly into set view target. Okay, so that's going to cut off these. So these three are no longer going to execute. Just this is going to execute. We'll compile that, go back to our level and run. And you'll see that there is something in the way. And what that is, if we go and we eject, you'll see it's a sphere. And that is what Unreal actually spawns if you haven't set up any sort of like character model or something like that. That's the default pawn. The default pawn is a sphere. And as you can see, it spawned at exactly 0, 0. So right on top of our ball. The ball is actually inside of it. And so it's actually just in the way. And you can see that it's textured, but if we go to our actual camera here, there is no texture, it's just black, and that's because it's using a lit texture, and because there's no light, there's no reflection, and you can't see any color. So let's go ahead and stop the gameplay there. And that is our camera setup. So we can take this event begin play, drag it back into set. Now, one more thing that we really need to do. You'll notice when we play, there's like a bright flash. And then it's sort of like the colors even out. And that is that auto exposure I was talking about before. And so what we actually want to do is turn that off. So let's select the camera. And if we go all the way to this, you'll see there's this auto exposure. We're going to select both the min and the max brightness. We're going to set them both to 1. We'll press save. Now if you press play, you'll see that that whole sort of bright effect is gone, and we get our legitimate color. So now we actually have our sort of like 2D looking setup here with no light effects or anything like that. The auto exposure is completely gone. The glow is gone. Everything is gone. It looks like a 2D game completely. Now the next logical thing to do would be to take on the player paddle movement. However, there is one thing that we should probably do input-wise first. If you remember, I said that we want to have sort of an AI demo and the player presses the space bar before being allowed to join the game and take control of the paddle. And so, without sort of breaking or hacking our design, it would be best to just get that set up and out of the way first, which is the attachment of the player controller to the new pawn, which is going to be our left paddle pawn, but only after the player presses spacebar. So how do we do that? Well, let's open up our player controller and we'll go to our graph tab. Just like the other graph tab, the one difference between the level graph and other blueprints is other blueprints have something called a construction script, which we'll be using a little bit, but probably not too much. But what we actually want to do is create a new graph, as I like to separate my input and my events. So we're going to create another graph to hold input events as opposed to game events. So on the left hand side here, we're going to hit this add a new event graph, and it's going to add in here, and we're going to call this input graph, like that, and it'll sit beside our event graph. So in the input graph tab, what we're actually going to do, now we're going to hard code the space bar, though you could set this up as like a mapping. So if you type space, you're going to see this key events, and underneath there we get space bar. Okay, and as you see, we have one execution for when it's pressed, and we have another execution for when it's released. Simple enough. Okay. So we can save that. So what do we want to do with this? Well, when we press the space bar, we want to notify our level here that it can map, it is now safe to map the player controller to our paddle pawn and to basically start a new game. Now, we don't have our game logic set up yet, so we can't do that part, but we do have enough set up that we can actually do the attachment. So how do we do that? Well, what we're going to do is we're going to add something called an event dispatcher to our player controller here. And we're going to call this on player join. Okay. What does an event dispatcher do? It basically allows two different blueprints to communicate with each other, to send each other notices. And so we're going to use it so that when the player controller signals that the player has joined, the map blueprint is going to be able to respond. Under our category here, we can make this paddle war. We'll say dispatchers for the category, so paddle war dispatchers. And then it has this copy signature from. We're not going to worry about that just yet. And the inputs and stuff, we'll just get it called first. So on released, what we're going to do is we're going to call our, actually let's just drag it in. So take it on the side, on player joined. Maybe we can't drag it. Okay. Maybe we can? Oh, we can. Yeah. Okay. So yeah, take it in, drag it. When you let go, you're going to get this menu. What we're going to do is call. And we're going to put that under release. So when you press the space bar, after it's released, this will call our dispatcher on player joined. And that's really all we have to do here for that. Now, because we're not going to know that it happened, afterwards, let's put a print string. And for the moment, we'll just say player joined with an exclamation mark like that. Just so that we know it actually happened. Okay, there we go. So now, if we go and we press play and we hit space, every time we hit space, it's gonna print player joined. Perfect so far. Okay, so now if we go back to our map here, let's select our get player controller, and we're gonna duplicate it again. We'll bring it over here, and we're going to drag off the return value, and this time what we're going to do is we're going to actually search for our Paddle War player controller. We're going to do this cast to BP Paddle War player controller. And we'll stick it right here. So we'll do that, connect them here with execution. And we've got our player controller going into the object there. Now, if this succeeds, we will get a new player controller object, which is representative of our Paddle War controller, not just the generic player controller type. And this will allow us to access specific things that we implement, such as our on-player joined, which is not present in the basic player controller. So coming off of this, we're going to type the on-player joined, and you'll get a bunch of options here. And what we're going to do is we're going to bind event to on-player joined. Just like that. Now, it has this sort of drop thing here for the event that we're going to actually do. And what we're going to do is we're going to drag off this, go all the way back here, let go, and at the very bottom, there's a create event. Oh, or we can do the add custom event for dispatcher, which is fine too. We'll do that. And we're going to call this event on player joined, like that. All right. So now, let's drag off here. We're going to print another string just to sort of prove what's going on. This string we're going to say, okay, we know. Uncheck the log, and we'll change the color of this one. We'll make it like a red color, orange. Compile it. Go back to our thing. Play. And now, every time that I hit space, the player controller says, hey, a player joined, and the map says, okay, we know. See how that works? So we now have communication between our player controller and our map object. So let's go ahead and delete the print strings now that we know that the connectivity is working. And let's do some actual logic here. So what are we going to do? Well, we're going to once again copy this player controller, and we are going to go to our level, select paddle left, go back to our map blueprint here, right click and go add reference to paddle left. We'll bring it in underneath, drag off the player controller, oh, it's possess. Yeah, possess. Yeah, select possess and drag the in pawn to be paddle left. Print another string here, and we'll just say that pawn is attached. Okay? Just to show that it actually happened. Save, run, and you'll see we now attach to the pawn. Unfortunately, it gave us a whole new camera view. And so we're going to have to once again set our view target just like that. And now the player is attached and our view has not changed. And now that we have a player controller that actually has a pawn attached to it, we can start doing most of our player input here. And go ahead and delete that print string, and we'll just go directly to our view. Yeah, just like that. Now, you might be wondering why we have it duplicated when it's the exact same, right? Well, that's a good question actually, and so what we could do is we could take it out of here, we'll put it back, that's just a cut and a paste by the way, and we could actually bind the event first. So let's bring this closer. And then following the event binding, we could change the view. Now what does that give us? Well, one of the really neat things about Unreal's blueprints is that you don't have to keep different execution paths separate. So instead of keeping this here, what we can now do is after this, bring that in like that. And now we don't have the duplicate code. Exact same thing, but it looks a little bit better. It shows how things come together. There's our space, and it's working as expected. Okay. So what's next for player input? Well, we're going to have to set up something that's called an axis mapping. Now there are ways that you can do this without an axis mapping, but this is the easiest way to do it. So if we go under the edit menu here and go to project settings, and then we go to this input selection, you'll see that we have action mappings and axis mappings. Under axis mappings, let's add the plus, and that will add a new one. You'll get a drop down, and you're going to get another one, and we'll call this move paddle, like that. We're going to add another key. We're going to set this to be W. And we will set the bottom one to be S for up and down. Now the scale factor is the value that's going to be associated with this up or down. So for down, we want a scale of -1. So that's going to tell us that this is going down. The scale for W is going up. And that will let us figure out exactly what direction we're going. Now let's say that you wanted to also allow the up and down keys to control the paddle. Like what if you want both? Well, you can do that too. You can just add 2 more. And we'll select up and down here. There's up, there's down, and once again we'll set the scale on down to be -1. And so now with this configuration, both WS and up and down will trigger this event called move paddle. So that's good, that's really all we need there. We can close that and save it. It saves automatically. We can actually close our paddle map blueprint for the moment. And now let's go into our input graph in our Paddle War player controller. Right click in here and type move paddle, and you'll see we now have these two options. We're going to use the axis event move paddle. And our value, the 1 or the -1, will be in this here, this axis value. Alright, so the first thing that we need to do is get a reference to our controlled pawn. Let's right click, type controlled, and you'll see we have this get controlled pawn. Now, we're going to take off this return value, and we're going to, once again, search for our Paddle War, Paddle Pawn, and we're going to do the Cast to BP Paddle Pawn. And this sort of does two things for us in one go here. The first thing that it's going to do is it's going to validate that we have a controlled pawn. And what this does is, I'll show you how this works. So let's drag off the top one here, and we're going to do a print string. And we're going to say move paddle was triggered. Don't log it. Color's fine. Drag off cast failed. And we will print another string. And we'll say not a paddle pawn. Okay. Uncheck the logging again, and let's change the color of this one. We'll make it red, just so it stands out. We'll put those there. Alright. So now whenever we press the move paddle, either WS up or down, this is going to trigger, which will call this, and then we're going to get one of these two strings, depending on whether or not we have a pawn currently or not. So before we press the space bar, if we hit one of our move paddle keys, we're going to get this message, not a paddle pawn. After we hit the space bar, we should get this message, move paddle was triggered. So let's test this. Let's go to play. Oh, right, axis events are actually every tick. So we don't even have to hit it to see it. And you'll see that it says not a paddle pawn, and it's just going to keep printing that until I hit space. So let's hit the space key and see what happens. Now you'll see move paddle was triggered. And now that move paddle was triggered, we could actually use paddle movement. Alright, so let's delete these strings. And that is how we are going to activate movement on the paddle. But what else does this cast do? Well, if it does succeed, then we get a reference to our paddle pawn specifically, not a generic pawn, which is going to give us access to all sorts of things eventually. Now, as I explained in the introduction, if you don't understand everything that's going on here, that's okay. Just keep going with it. Keep following, keep doing, because that's what's going to make sort of this type of thinking make sense. What you're really learning here isn't code. What you're learning here is how to take critical thinking, the idea that you come up with a concept, some sort of a project, and then how do you break that down and turn it into actions that then result in your project coming to fruition. So that's really what we're doing here. So, you know, like if things like casting isn't making sense to you, don't worry too much about it yet. Get through the project, then you'll be able to review the code of the project that you built and see how things that you do affect different things. So let's compile this and we'll start doing our input. Now, input for this is actually pretty easy. So in our player controller here, actually, you know what? Let's set this on the pawn itself. So we will need this. Good. Okay. Yeah, we'll save all this, and let's open up our paddle pawn blueprint here. So it's empty, there's nothing in it. What we are going to do is add a variable. So let's add a new variable. And what we're going to do is call this base speed. Hit enter. And down here in the details, we're going to have to adjust some stuff. So the variable type, it's going to default to a bool, which is a true or false value. What we want is a float value. And a float value you're going to see a lot in programming, and especially game programming. And it's basically any number that can hold a decimal place. So like 4.1 is a float. 4.0 is a float. Basically, it's any number that could be positive or negative and has a decimal place. And it's within a certain range, but don't worry about that too much yet. We're going to make this one editable. We'll make the tooltip the base speed of the paddle. And this will be the speed that the paddle goes in units per second before any modifier. So like, let's say later on that we add difficulty and stuff. Difficulty might add a speed modifier, but the base speed will be sort of where we start at. We'll select this expose on spawn, and that will allow you to set a base speed other than the default when you spawn a paddle. For the category, we can do a paddle war, pipe symbol, config, like that. For the slider range, this is sort of like the values that are valid, that we're going to consider like a valid range. Now, a minimum of 0 kind of makes sense, although you might want to have like a base, like a minimum speed value. Like you could make it 100 or something. The maximum, we will make it 300. And so that would be 300 units per second, meaning that for the paddle to effectively travel from the bottom of the screen all the way to the top of the screen should be just under 2 seconds, which I think is probably an okay starting speed. This is the type of stuff that we would want to play with and get a feel for. And then the default value, the starting speed, we could make, let's say, 200. So it'll take 3 seconds by default to get from the bottom to the top, or just under 3 seconds. So now that we have our base speed, let's go back to our controller here. We're not going to do anything too fancy. There's lots of different ways that we could do movement in Unreal Engine with physics or But what we're going to do is just a simple translation, nothing fancy. And so the way that we're going to do that is we're going to drag off our pawn here. And we are going to type add. And we get a bunch of different options here. One of which is an add movement input, but that's not the one that we're going to use. We're actually just going to use an add actor local offset. Now, all we need to do is give it a new location, which will be added to its current location. So what we're going to do is drag off the delta location and make a vector. So we have a brand new vector here. We're not going to move on X, we're not going to move on Y, but we are going to move on Z. And this will be where we apply our axis value, which is going to be a 1 or a -1, indicating the direction. So what we're going to do is drag that here, and we're going to multiply it. Float times float. And the result of this multiplication will go into Z. Now, what we need to actually multiply to get our value is a little bit more than the axis value. Of course, we're going to need the speed of the pawn, so that's going to be the base speed that we set up there. So we can drag off the pawn and get our base speed. Actually, we'll stick that here. Maybe we'll move that one to the top and put this one on the bottom. That's a little bit nicer. And we need one more thing, and this is because we're not working in seconds yet. We're working in frames, and this input axis event runs every frame. But we want to convert our movement to seconds. And so to do that, we times it by the delta seconds, which is the fraction of a second that the last frame consumed. So the delta seconds allows us to smoothly interpolate over time, regardless if you're running at 120 frames per second or 60 frames per second or 9 frames per second. It'll adjust our movement accordingly. The last thing that we're going to do is we're going to check this sweep. And right now, this isn't important, but later on we're going to use simple collisions to prevent the paddle from going out of the game board, and so we're going to scan for collisions as we move. And that is pretty much everything that we should need to make our paddle move. So if we save, press play. Now, of course, it's not going to move yet, but if I hit space, now suddenly it moves. And I'm able to control it using W and S. It looks like Unreal is lagging a little bit there, probably due to the screen record and stuff. And up and down, so they both work. Alright. So that is how that works. And again, it's disabled. So the AI will be playing while this happens, and then you'll press space. Now you can play, and now you can move the other paddle. So to set up the border collision, what we're going to do is just add two collision volumes into the level here. So we're going to go to volumes. And we're going to add a, where is it? Blocking volume here. So it's this giant sort of, I don't know, transparent box thing. Now, unfortunately, in Unreal 4.0.2, we don't actually get the location with brushes. They do add it to later versions, but in this version, we don't get it. So how are we going to make sure that this thing is centered? Well, the way that we're going to do it is using the other views. So if you go to this sort of box-in-box thing here on the corner, you can click it and get a nice sort of 2D view of all sides of our level. And we can just center it this way here. See that? Nicely centered. Nicely centered. Now, obviously, this box is not exactly where we want it, nor is it the size that we want it. So let's set the size up first. So the mobility will be static. It'll be a box type. The X on this is going to be 200. And I'll show you why in a moment. The Y will be 800. And the X can be something like, I don't know, 20. This should be fine. We will keep the generate overlap events with invisible wall, so that's all set up properly. And then all we need to do, you'll see it's nicely shaped to fit our game board area. And we can just drag that up so that it is at the very top and lined up with our top there. We can name it and we'll call it the top boundary. Hold Alt and drag it down to duplicate it and put one at the bottom as well. We'll call this one the bottom boundary. Alright, we'll go back to our full view here. Save. And now if we play, hit space, move this down, and you'll see we can no longer go outside of the borders of the game board. So that's our movement of the paddle. We have our boundary, and now that we have our boundary, we can actually set up ball movement. And this is where the bulk of the code is going to go, is pretty much in ball movement and how the ball will respond to the paddles. as well as the AI. The first thing we're going to do is get the ball bouncing between the two boundaries. So let's go ahead and we'll hit go to our BP ball here, and we'll open that up. We're going to right click and we'll create a begin play event. And so the moment that play begins, we'll start moving the ball. Actually, sorry, we don't want to begin play. We want event tick. Yeah, event tick, just like that. Which also runs at the same time as begin play, or starts running at the same time as begin play. So the very moment that the play begins, we're going to start moving the ball. Now, we're going to add a new variable here, and just like with the paddle, we'll add a base speed variable. We're going to make it editable. We'll say this is the base ball speed. We'll expose on spawn. Category will be paddle war, pipe sign, config. And the range will be 0 to, let's say, 400. 400 would be pretty high. That would basically cross the board in like 2 seconds. I mean, we could go higher. We could say 800, and that would basically do a second across the board. You probably won't ever go that high, but this is the min-max range. We'll compile, and we will give the ball a default speed of, let's say, 250, make it just a bit faster than the paddles. Okay. Now we're going to need one more variable here. So we'll add a new variable, and we're going to call this the ball direction. And this will be a vector. It's not going to be editable. The tooltip will be the ball's current direction. We're not going to expose this one on spawn. We're not going to make it private. And as for the category, we'll put it under Paddle War Data. Save that, and we'll give it a default value of 1 on the y-axis. So that is a vector that is facing this direction. Remember how we set the default forward vector to be y positive? So that is y positive. We are facing this direction with the ball. By default. No, we're, like I said, we're going to randomize that and it'll choose a direction later on. But to get started here, this is how we're going to do it. So with all of that, we can now drag off of this event tick execution node, type add, and once again we're going to get that add actor local offset. Now our target is set to self, which is perfect because we're inside the ball. So we are the ball, and so self is appropriate. We want to affect ourselves. The delta location, right click, type out location, and we're gonna get this get actor location. Once again, the default is self, which is exactly what we want. Dragging off of here, you're going to get a menu like this, and you're going to get this option to break a vector. That gives us the individual x, y, and z that are stored in that vector. On this side, where there's the delta location, we are going to make a vector. And you can probably see where this is going. The x, we're just going to drag directly into x on the new vector. And we're going to do the same. Actually, we'll do y first, I guess. So we'll do the same for z for now. And off of y, what we're going to do is a multiplication. Or sorry, no, off of y, what we want to do, yeah. Sorry, you know what? We don't actually need these. I got confused for a second there. That's what happens when you sort of build this stuff on the fly. We don't need these. What we need is to take this delta seconds. We're going to times this here. Times it float by float. We'll add our pin. Our base speed's going to go in here. This is going to be our delta seconds. Just like with the paddle, basically. The exact same thing. That's going to go into our Z vector there. We'll sweep. Actually, we don't want to sweep. Should be fine. Bring this closer. Okay, so now we've made our new location. If we compile and run this, it's not doing nothing. I am silly. Wrong value. This should be the forward vector. We already had the delta. I was timesing the delta in twice. So what we actually need to do remove that pin, and we're actually going to times this and do a vector by float. We're going to get rid of this make vector. Sorry. Get forward vector. Get actor forward vector. That's the one I wanted. Alright, now do we get motion? No? Why not? Oh, because I didn't replace the ball with the... Oh, man. I see it's one of these recordings. I can either record this or we can just laugh at how silly that went. Alright, so what we need to do, put our ball here. We have to replace our ball. Yeah, we haven't done that yet. Alright. Now it is a BP ball, not a static mesh actor. And boom, there we go, it's gone. Took right off, that didn't take long. That might not be the right value. So let's try this again with the make vector. So I'm pretty sure this is what it's supposed to be. Definitely moved, but where is it moving to? It's moving way too fast. Let's slow her down. We'll make it move it 20 units a second. What? Where's it going? Oh, there it goes. So it is working. It just went the wrong way. Yeah, not the right way. Oh, right, because I rotated it. We want it on X. Try that. There we go. Okay. Now let's put our base speed back to, say, 250. There we go. Boom. Alright, now that we know that works, we can take this make vector out, and what we're actually going to do is put our ball direction in. We'll get that here. And actually put ball direction on top. Take that, we're going to times that by float. Put that there. And now that's going to go into our delta location. And we should get the exact same thing that we just got with the other one. Except that it's not accounting for the directional change. We want it not on Y, we want it on X. Alright. There we go. Same thing. Now that we have the horizontal movement, working with our ball direction, what we're going to do is actually rebound the ball between the paddles horizontally. So we will move over to our game area here. And the ball is selected. Make sure ball is selected. And then we can go back to our BP ball. And we're going to right click and type overlap. And there's these events under collision. Event actor begin overlap. We're going to select that. And we can just drag it under tick. So this is going to fire every time that the ball hits something. Now that could be the paddle or the boundaries, or later on even the trigger box if we had set it to overlap that we're going to make to do the scoring. But basically it allows us to detect when it encounters another object. And then to figure out what that other object is, we can cast this other actor. So we're going to do that here. We're going to drag off other actor. Type paddle. And you will get this cast to BP paddle pawn. Paddle pawn. Say that 3 times fast, eh? Okay. And if this cast succeeds, we know that we've hit a paddle. And so what we're actually going to do is add an actor local rotation. And in our delta rotation, we are going to put 180 degrees on Z. So that's effectively going to turn the ball around and have the forward direction now facing the other paddle. We'll save that, play, and let's see if that works. There we go. Now the ball will bounce between our 2 paddles.